Okay, this is the last question. At last, the last of part 2, the practice midterm number 1. And the question is, it takes 41 pounds of soybeans to make 1 gallon of biodiesel. 1 bushel of soybeans weighs 60 pounds. 1 acre of land can produce 38.1 bushels. And the U.S. uses 3.0 times 10 to the 10th gallons of diesel per year. So the question is, how many acres are needed to satisfy the annual demand for diesel in the United States? And this is going to be a straight up dimensional analysis problem. I'm going to use scientific notation in the effort to express everything. And really we're going to get more information out of the order of magnitude at the end of the day than we are about the mantissa and get me close enough to answer the question effectively. And so let's start with what part of this question would be the best point of departure. And personally, my favorite is the annual demand. So start with that statement. There is 3.0 times 10 to the 10th gallons per year. Okay? And now I'm in gallons, and I need to go from gallons to soybeans somehow, and let's take, where's gallon first appear? Oh, it's up there in pounds per gallon. So, and it takes 41, or 4.1 times 10 to the 1 pounds for every 1 gallon. Okay? And now I've gone from gallons to pounds, and now I'm going from pounds to bushels. And there is 1 bushel, which I'll denote as bus. I'll throw this under the bus. And 1 bushel weighs 60 pounds, so that'd be 6.0 times 10 to the 1 lb. Okay, so we're now in bushels, and now I'm going from bushels to acres. There is 1 acre for every 3.81 times 10 to the 1 bushels. So we're now we've carried this to the point where we need to, because we asked the question, how many acres are needed to satisfy the annual demand. So we start with the annual demand, and we just plug through it till we get acres. So now this is going to be an equality. So let's now look at what we need to do. The mantissa information and the characteristic information, the order of magnitude, and the order of magnitude is going to turn out to be the revealing point. So let's take the mantissa first. That'd be 3.0 times 4.1 divided by 6.0 times 3.81. And that is all. Did I miss anything? Nope. That's the mantissa information. Anticipation, I call it. And times. And now let's get the characteristic or order of magnitude. 10 to the 10th times 10 to the 1 divided by 10 to the 1 So I could guess, I could cancel those out. But let's do it. Let's do the whole thing up this way. 10 to the 10th, so I don't lose track, times 10 to the 1, and that's it, divided by 10 to the 1 times 10 to the 1. And this is equal to, okay, let's get the order of magnitude first. 10 to the 10th, well, 10 to the 1 cancels, so it's 10 to the 10th divided by 10 to the 1 is times 10 to the 9th acres. And now let's look at the mantissa. Well, 3 divided by 6 is 1/2. And so that 2 goes into 4, that's around 2. So that cancels out. It's 2 divided by 3, so it's going to be around, or actually this is closer to 4. So I could take this as 4 divided by 4, ballpark. That's 1, and this is 1/2. So I'd say that's around, so I'll put a little squiggly line here. 1/2 was just 0.5 times 10 to the 9th acres. And that's equal to 5.0 times 10. Now I move this 1 to the right. And so that means I subtract 1 from this, times 10 to the 8th acres. Okay, so it's all squished over here in the corner, but it carries the salient features. So it's around, well, 10 to the 8th is 100 million. So it's around 500 million acres. And just for your information, there's around 3/4 million farmable acres. So it would take 2/3 of all our farmable land. And just in case you were contemplating the viability or the efficacy of growing our diesel, we'd have to find something else to eat, because we sort of need the land. But I'm not going to go off onto that tangent. This is what I wanted everybody to practice, was using these simple rules and scientific notation, understanding order of magnitude and mantissa and precise information. And scientific notation does give us a definite advantage for the calculation. We could probably, if we wanted to spend a little more time, I could get through and do this. I could easily multiply 3 times 4.1 divided by 6 times 3.81, and we could give you the exact answer. But this carries the salient features I'm looking for. It's all in the setup, and that's what I'll be looking for on your test, is this setup here. You could do this, which is more than explicit. But what 99% of it is this part. And then there's the answer is important, but I'm really more interested in the order of magnitude than the mantissa here. Okay? So that's it.